Assalamualaikum and hi. Okay, last video we learned about the EMOSFET transistor, and now in this video we will learn about the EMOSFET. So if we can recall back the construction of the MOSFET for both E and also D, actually they have a similar construction. Okay, definitely we can see there is a metal contact at D, G and S, and then we have silicon dioxide layer, and then we have the n-dop region, then this is the p-type. Okay, the difference between the E MOSFET and D MOSFET is this one. Okay, this is very important. Where the E MOSFET actually there is no physical channel. Okay, here you can see in between the n-dop at D and n-dop region at S, there is no channel. Okay, so it means that if there is no channel, so there is no electron flow, and it will result ID equal to 0. Then if ID equal to 0, so how this transistor can be on? Okay, let's take a look into detail for the operation and characteristic of the E MOSFET. Okay, the first thing that we must remember, always remember that the E MOSFET actually can be on if the VGS is greater than VT, like the diagram, the second diagram here. Okay, VGS greater than VT. So the first diagram is the operation when the VGS is less than VT. So what is VT actually? VT is a threshold voltage for the transistor. It has threshold voltage that the VGS must be greater than this value so that it can induce a channel for the E MOSFET. Okay, let me take a look into detail. Okay, see the diagram for the second diagram here. Okay, see in this diagram there is a channel. Okay, so how it works? Okay, like I said before, VGS must be greater than VT, and this VGS is actually in positive value. Okay, so when at terminal G, okay, is positive because of the VGS is positive here, so we get the positive at the terminal G. So this positive gate will attract the electron. Okay, will attract the electron. Will attract the electron in the N channel. So actually in the N channel there are a lot of electron. Okay, and what happened with the hole in the P channel? Okay, so the hole in the P channel will be pushed away from the P channel. Okay, and then what happened? The electron in the P channel, okay, because we still have electron because it is minority in the P channel, then that electron will be near at this region. Okay, so it will induce a channel or it will create the channel. Okay, so finally this channel will be greater and bigger and bigger and bigger and become like a physical channel. So when this channel is already maintained and electron is many enough, so it can flow from the S to D. So the current will result in direction of D, from D to S. Okay, so definitely the operation of E MOSFET, again I will explain in two mechanisms. The first one is by applying the VGS greater than VT. It is a must, okay. And then the second one is to apply the VDD greater than 0. So actually for the first one, when we apply the VGS, actually it will generate or it will induce the channel. So it control the gate, okay, the amount of the current. And then the second one, when we apply the VDD, actually it will generate the current, whether we want to increase the amount of the current or it will getting less current. Okay, let's we take a look for the VGS positive, and it must be greater than VT to be on, okay, so that the transistor is on. So for the first one, first diagram here, okay, actually for this three diagram, I already said VT is same. VT is 3 volt for diagram 1, diagram 2 and diagram 3. But I increase the VGS from 4, then increase to 6 volt and also to 8 volt. Okay, we can see what happened to the channel. Okay, because we know that when VGS equal to 0, there is definitely no channel. But when we increase from 1, 2 and 3, the channel actually still 0, no channel, until we increase or we exceed the VT level, then the channel is created, like diagram number 1. At diagram number 2, okay, we see that the channel is getting wider, okay, because the positive voltage here, positive potential at gate will attract more electron, okay, in the N channel, and at the same time it will attract more electron minority at P type, and the hole here, okay, in the P type, we push away, so it will go away from the this area. It become, here is more electron, okay. So we increase to VGS equal to 8 volt, so the channel is more bigger than the previous one, okay. So it will result more current, okay. The current is getting higher compared to the previous one. Now we continue to the second process, which is applying the VDD greater than 0 volt. Here, when I put the VDD greater than 0 volt, which is a positive voltage here, it means that VDS is positive, then at the D terminal is positive here. So what happened for the EMOSFET operation, to generate electron flow from source to drain, the positive VDD is applied, and the gate terminal must be positive here. Gate terminal must be positive, and its value greater than threshold voltage VT. As this VDD or VDS is increased, then here the reverse bias occurred, and the resistance at this area is getting higher. Therefore, the depletion region will grow, and what happened that after that the pinch off will happen at this area, okay, and then the saturation current will be obtained. Means when the pinch off happen, the IDSS is the maximum current on that time, and it will refer as the IDSS. we take a look when these two process applying the VDD greater than 0 and when VGS greater than VT are applied together. Okay, when we apply together here, I choose VGS equal to 6 volt. Okay, during this time, this VGS is greater than VT, which is the 3 volt. Okay, it means that the transistor now is on and the channel is there. See, for the first diagram, the channel is here. Okay, when the VDS is 2 volt, okay, VDS is 2 volt, so normally it will the electron will flow and we get the current. Okay, and then when we increase the VDS, okay, here the reverse bias happen here and the depletion region will be getting bigger and bigger. Okay, see the depletion region here. Okay, when I increase to 6 volt, the VDS here, we increase the 6 volt, the depletion region is getting bigger until the pinch off happen here. Okay, so that during this time, the current is at maximum level and we get the IDSS, which is the saturation current. So we can see in this graph for the VGS equal to 6, this one, the blue color, okay, the graph, when it reach higher and higher, when the current is increased, so at this point, actually, at VD set, this is during the VP. Okay, the pinch off happened at here. After that, the current will maintain at the saturation level. Then, if VGS is decrease to positive 5, okay, if decrease to positive 5, the depletion region, okay, is it will develop very fast compared to the VGS equal to 6 volt. That's why we get level of the current is lower compared to the VGS equal to 6. Okay, same goes to the VGS equals to positive 4. The depletion region, okay, the operation in the depletion region is very fast and make the current getting smaller here. And finally, when the VGS is 3, okay, which is this VGS is actually same as the value of the VT. Okay, at this time, when VGS is 3, the channel is not developed yet. Okay, the channel is not developed yet. So there is no electron flow in the transistor because there is no channel. Therefore, we get ID equal to 0. You can see the red line here. This is for VGS equal to 3. Okay, so finally, from 3's characteristic, okay, what the important parameter now is the VGS3, where we call it threshold voltage. Okay, so you can understand from here, the threshold voltage will produce ID equal to, here during this time, ID equal to 0. Okay, then means that the transistor is off.